All right, hello again, everyone. Thank you for joining me for an overview of our latest GLL 3.2 VenuePolar for our IV6 system. My name is Dave Howden. I'm Technical Services Manager for the Loudspeaker Solutions Group based here in Chester, Pennsylvania. I'm going to move pretty quickly through a review of the IV6 system, show you what's new in GLL version 3.2, and try to spend a better part of my time doing live demonstrations. My contact information will be displayed at the end. If you want to get into more detail with me, feel free to contact me directly. So with that, let's get going. So the IV6 modular vertical array system's been around, available for about 3 years, but we've made some major refinements in the software, making it easier to use. The system's modular, adaptive, and scalable. It can be configured as a line array, a constant curve, or somewhere in between as an adaptive array. It features our VenuePolar and passive acoustic optimization API and plugins. There are indoor and outdoor models available for the IV6 systems, and they're made here in Chester, Pennsylvania. A couple of installation examples, just things, applications to have in mind while we're going through the information here. The system lends itself well to any sort of auditorium spaces, indoor spaces, outdoor spaces. We do have our weather-resistant models that can be used and left outside 365 days a year in pretty much any environment. Of course, the outdoor systems do require custom rigging to match the structural needs of the venue. So a quick review of the IV6 system. High performance, high output. It's a two-way modular vertical array and subwoofer system. We've made it easy to configure the system with very low profile and aesthetically pleasing hardware options. There are two full range cabinets available, the IV6 1122, the O5, which is a 5-degree vertical dispersion, and a 15-degree vertical dispersion. They are passive only systems, and each element is 16 ohms. And the intention of that is that we can parallel, 3, 4, or 5 elements together, possibly 6, depending on your attenuation, and run them off of a single appropriate size amplifier channel. Both systems have 120-degree horizontal dispersion for them also, and you see the weights and dimensions below. A subwoofer system is also included, and it can be, part of the array, so hung, on top of the array, behind the array when using the GlidePoint array frame system. 800 watts continuous power handling, single 18-inch system, and all the other attributes you would generally expect from a single 18-inch subwoofer. We have a variety of indoor array frames, and our systems are also available both in black and white, obviously color matched rigging hardware for all of the accessories also. One of the options that we have is our GlidePoint array frame lift point. It's generally intended to be used as a single point hang. We can mount subwoofers on top of it and then transition to full range elements. Or we have a sub behind array frame, which allows the inclusion of subwoofers behind the array in a standard configuration or a cardioid configuration if you choose. Either way, the systems are mounted with the single PYEN 750 hoist ring point. There is also a selection of other grid to structure, mounting accessories available from our friends at Polar Focus, who designed and manufacture all of the rigging for the IV6 system, and you can look at some of those other convenient grid to structure attachment options at linearrayframes.com. So the sub behind array frame, or the SBAF, Again, you've got two infinitely, essentially infinitely adjustable glide points. You can see on the top mounting bracket where the carriage is, where your PY1 would attach. So you've got a trolley back, that moves back and forth back there to achieve, balancing of the system. And independent of that, there's also a separate trolley, for the full range array. So we can get, we can level our subwoofer system, but also achieve the needed down angle for our full range systems. We do have a separate rigging calculator to figure out the balance point for the array. It was a little bit too much to ask of Ease Focus to calculate this. So if you look on Cornerstone and look for sub behind array frame, you'll find a calculator where if you choose this configuration, you can plug in the weights, and it will do the calculations for you to find the balance point of your array. We also have a light array frame, which is also used as a pullback bar, which we'll talk about quite a bit today. It's not as feature rich as the GlidePoint array frame, and it's only designed to suspend the IV6 1122 elements. We can support a whole lot of elements, with inclusion of this being used as a pullback point, as seen in the picture on the right on the bottom. And again, we'll get into a few details on that as we go forward. But point to remember: indoor only, only designed to fit the full range elements. Can be used as a pullback bar also. So passive acoustic optimization. What is passive acoustic optimization, or PAO as I may refer to it quite often? PAO essentially is used to shape the IV6 full range system's vertical lobe through passive beam forming, and we do that through the contouring, or as I may call them, the attenuation jumpers on the IV6 1122 full range cabinets. There's over 55 different response profiles that can be chosen, but we don't make you choose those. We calculate them out for you. We'll get more into that, but this provides us the fine control of our vertical beam forming for the full range systems. There's 3 different splay increments between the 2 different vertical dispersion full range cabinets. We have 3 different splay plates, which we'll talk about. And as I said, the full range elements are intended to be wired in parallel and processed oftentimes by just a single amp channel with its FIR DSP setting in the system. Splay brackets, they're aluminum brackets. Again, we calculate these out. We don't make you guess which ones to use. We can either do a tight pack or a 0 degree splay, a 2.5 or a 5 degree splay between elements. And these are designed specifically, for IV6 to optimize the overlap regions in between them, and also provide, a very smooth transition from different vertical dispersion elements, say between 5s and 15s. We don't need a separate DSP or amp channel, in transitioning between 5 and 15 degree elements. And the picture on the right hand, that's shown, with the side panels removed from the IV6. There's some convenient handles there for the installers while they're putting the system together, but then side plates go over that to completely conceal the rigging. The contouring controls, which I spoke of, where we can come up with those 55 different response profiles on the back of each full range element. For the 1122 systems, we can passively provide up to 15 dB of attenuation per element. Additionally, we also have the option of providing up to 6 dB of high frequency attenuation or tapering per element, in order to achieve that vertical beam forming, which PAO is really good at. The attenuation for the full cabinets is done through an extremely high quality transformer, designed and manufactured by us, whereas the high frequency tapering is done through usual appropriate size resistors to dissipate the heat. The contouring controls on the back of the 1122, just a quick overview here. You can grab the manual and dive in deeper on this, but this is where the settings that come out of our Ease Focus 3 report on a per cabinet basis tell us where to set the cabinet and the high frequency attenuation based on the answers from the Ease Focus calculation engine. So what is VenuePolar? VenuePolar is a software plugin API that is designed for use in Ease Focus 3, and it's exclusive to the IV6 system at this time, and it integrates seamlessly with our PAO. VenuePolar automates a number of the complicated functions for designing an array. It'll choose our element type, our interplay between elements, the contouring profiles on a per cabinet basis, and it also help us provide a subwoofer quantity estimation based on user parameters dialed into the VenuePolar API. In the end, VenuePolar relies on creating its predictions in the Ease Focus calculator. Provides the predictions based on the properties of your modeled seating areas in Ease Focus 3. It's all about the seating areas. And to that end, like with any sort of modeling, predictions only as accurate as your model is. So ensure you get it right in the program with your hang heights, your seating, whether it's sloped or flat, standing, sitting, or whatever may be appropriate. We also have user input fields in VenuePolar to allow you to, if you have a performance spec, it needs to be 100 dB system or something of that sort, we could dial that in, and we'll dive into that into the live demo. So that it suggests an appropriate array that can meet those SPL needs. VenuePolar creates an extremely easy to use, streamlined, and time-efficient design process for system designers in a common software package. The API in VenuePolar, especially with the 3.2 release, is just a giant leap forward and enhances all the capabilities within the API and leveraging the power that Ease Focus 3 already has. We use a lot of highly intelligent automation inside of it to speed up the design process, and this allows intermediate users to achieve great performance in your common, relatively acoustically friendly spaces. But also, advanced users have a lot of options for tweaking the array performance with our wide range of user controls. If you really want to get deep in it and chase that last decibel, you can come up with some very extraordinary outcomes with some tweaks. But VenuePolar on its own, I would say, just provides extraordinary outcomes pretty much every time you run it anyhow. So what's new in GLL version 3.2 of VenuePolar, which replaces the previous release from back in February roughly? We've made some significant upgrades to the rigging calculator. The mechanical folks will really appreciate this. We can now add the light array frame pullback bar on the bottom of an array to help us in situations where that may be advantageous. If you're using the light array frame, you may have the likelihood of running into an array configuration, especially when you get beyond 6 or 7 elements, where a pullback bar is required, and the program will now flag you that a pullback bar is required within the system. Pinpoints and rigging points should be selected in the VenuePolar properties rather than the EF3 screen. And the pinpoint or the hang point of your array, that point where it balances and gets the array frame aimed at the proper angle within your model, is now reported in the Loads tab, usually in section 6.3 of the Ease Focus report. So we prefer to let VenuePolar calculate the frame angles, but if you choose to tweak things on your own, there's a number of options available within the Loads tab now to do that. If we're doing a single hang GlidePoint array frame or using the light array frame, if you change the pinpoint in VenuePolar, it resets the Ease Focus frame angle. Again, we typically want to work in the VenuePolar Loads tab when making changes. If you change angle in Focus 3, VenuePolar will reset to closest pinpoint. There may be a small offset in angle, but we're usually only talking tenths of a degree, not a big deal. For all rigging, essentially if the center of gravity or the red dot you see behind the array is behind the last pinpoint, whether you're using a GlidePoint or a light array frame, it's going to flag you and tell you that a pullback bar is required in order to achieve the down angle desired in your design. If the center of gravity is in front of the first pinpoint, well, custom rigging will be required, and that's another discussion, but we don't see that really often at this point. But in the end, pay attention to your safety rigging factor. You can dial in your desired safety factor to meet the codes that you're trying to, but pay attention to safety factor and any warning flags that Ease Focus may throw at you. We have the ability to do a double hang of an array. A variety of reasons you might want to do that, whether it be for stability or on the light array frame, there aren't rigging points really behind the array. So you can choose to, the certain geometries of arrays, do a double hang and add a rigging bar to the bottom of the system, but it all depends on the center of gravity of the array, whether or not you absolutely need it, or if you're just adding it for stability purposes. If we change a pinpoint in VP, recalculates the loads in real time in our Loads tab. We can also click default when we're doing a double hang, and the rigging will revert to the last rigging point on the top and pinpoint 1 on the bottom. If we choose to do a single hang and we require a full, a pullback bar perhaps. Again, if you change the pinpoint in VenuePolar, all the loads get recalculated and the EF3 frame angle remains the same. If you click default, the default button to the right of the pinpoint, VenuePolar will reset to the pinpoint nearest and in front of the center of gravity. Again, if you change the frame angle in the Focus 3 side, VenuePolar will reset to the default pinpoints and then recalculate the loads. And just pointing out on the bottom, I did add a pullback bar to this one, and we'll get into how to do that, but you bring it in as another cabinet manually on the left-hand side of the screen, and then you have to re-import your array into the system. So there's a lot more depth to go into in the rigging on this, but hopefully for those mechanically minded folks, they appreciate the very hard work that our mechanical and acoustics team put into this. Also new in version 3.2 is bill of materials for IV6 VenuePolar systems. We can find a bill of material for the current selected array when we produce the report, and also at the end of the report, section 7.5, a complete bill of materials for our rigging hardware and cabinets is produced, thus saving you time, counting elements, wondering if you counted the right number of splay plates between cabinets. So this comes out in the PDF version of the report, which I'll try to remember to produce one during my demonstrations. The most exciting, to me at least, from a designer point of view, is in the previous version of VenuePolar, we had to manually synchronize our cabinets from the VenuePolar prediction over to the EaseFocus 3 calculation engine side. We don't need to do that any longer. VenuePolar will, after you calculate an array, it'll automatically synchronize the box counts and all the rigging hardware, with the exception of the pullback bar, which you need to add manually, over to the calculation engine. And vice versa, we can bring an array in from EaseFocus to VenuePolar also, which we've also added a great feature for if you decided that you needed to or wanted to build your own mechanical array in the EaseFocus 3 side. You can still make use of the powerful calculation engine for optimizing those attenuator or contouring profiles on the back of each element, but leave all the mechanics of your array be the way you designed them. And when you transfer the project from EaseFocus to the VenuePolar engine, you'll get a pop-up asking us, do you want to optimize the filters? And it'll only calculate filters. It's not going to do anything with your hardware. You can simply click yes or no. Ultimately, the optimizer will give you the best filter settings for the given array that you designed. If it's a poorly designed array, all I could say is the optimizer will do its best. I'd always, tell you to, let VenuePolar take a crack at it, even if you have to limit the number of cabinets in it. It'll do the best it can. Also, notable, if you get into really long arrays, VenuePolar can only calculate mechanical arrays up to 12 speakers, but we've got some workarounds for that if you want to contact the solutions group. We'll be happy to help you out if you get into really large arrays. So VP, retain and build on the unique features in the previous release of the GLL. We've increased the functionality and accuracy of the rigging safety calculator module, including the pullback bar now. We still have the user ability to fine-tune element contouring settings. Again, I find that usually I don't, but sometimes you dig really deep into it, you might find yourself tweaking just a little bit here and there, but certainly no make or breaks. Detailed reporting is in the EaseFocus report for a bill of material now. And most importantly, it's designing with VenuePolar, it's a familiar EaseFocus 3 workflow. It's not another program to learn. And for advanced users, you can export the array configurations from Focus 3 and then import them into your EaseFocus 4 model if you're getting into deeper work where it requires full room acoustic evaluations. We also provide additional support for subwoofer configurations. We can suggest a quantity of subwoofers based on array size and our chosen SPL target, above, behind, ground stack, or none. And I mentioned the sub-behind calculator, which is available. Check out Cornerstone to find information on that calculator. So how does VenuePolar work? To produce the VenuePolar, we automate the calculation of the number of elements, the vertical pattern of each element, the splay angle or splay plate between the elements, the magnitude, the magnitude of each frequency range using the contouring controls is calculated. And by adjusting the above properties, we can, VenuePolar, optimizes an array that has the proper vertical pattern and intensity to address your listening areas. This is what we call the VenuePolar. So for most any listening area, the goal is to provide uniform sound coverage from first to last listener. Sometimes we have the right hang height, sometimes we don't, but help us answer these questions using VenuePolar. We want to have even frequency response through the space as well as sound pressure level. Ease Focus 3 doesn't have anything to do with intelligibility, so you have to first ensure that IV6 is appropriate for the space, because intelligibility is right up there on the list of things we have to achieve for a successful system. We need to calculate an array that overcomes inverse square law, based on trying to tweak the array size and the attenuation controls to get that nearest listener, or D1 on the screen, a very similar listening experience to the furthest listener, D2, further away. And it's not uncommon at all for us to have a 20 decibel delta between nearest and furthest listener, these are applications where using a highly directional speaker, such as a line array, can be very advantageous, especially if we don't have the ability or aesthetic desire to place delays deeper into a room of point source cabinets. So a typical point source radiation pattern, again, usually not ideal for long throw. Yeah, could you put delays in here? Sure, you might. You might be able to halfway back into the room, but we're here to talk about the solutions, based on IV6 systems. So a point source array at a 20 some foot height isn't going to provide even coverage to the back of a room with a typical system. Using a VenuePolar optimized radiation pattern, using 5 elements in this, we're able to, through those attenuation controls, shape that vertical beam, providing a lesser but even amount of energy in the front compared to the listeners further back within our listening space. All right, so let's get started. Quick overview on this here. It is important to note that to use GLL file version 3.2, you have to upgrade to Ease Focus 3.1.14, and the link is down there. It will not work on .12 or .13, so make sure you upgrade. You can download from our support and downloads area on the Biamp.com website the IV6 version 3.2. Once you download the system, import the system definition file. First step, go to insert a speaker on our Ease Focus screen and select your version 3.2 of the VenuePolar GLL. A quick note, if the VenuePolar API window on the right-hand side is not shown on the right panel, you may need to go to your view screen and enable the secondary properties window if it's not showing up. Again, VenuePolar is only applicable to the IV6 system, but if you don't see the API on the right-hand window, there's another tab next to rigging. Go to view and check the enable secondary properties. I'm not going to go through all these in detail. I'd rather do that in the live demonstration. So we'll leave these screens up. We have a lot of different options, for the designer to use. And we have a wonderful web help button, which will take you to an online resource that we update as needed, explaining all the details of what all the different functions do in the Start, Array, and Loads tab. Our target audience areas is one I'll point out being extremely important. Those areas, assuming the array intersects those audience areas, the ones that you check is what the VenuePolar will be developed based on. If the line is not intersecting an audience area, it won't take it into consideration when calculating the array. We also have fairly typical controls. We can enhance front row coverage. We can dial in what we want the SPL system of to be in dBA. Can also optimize to a frequency. If we know we have a very long low frequency RT time, it may be more important to optimize to a lower frequency A longer array provides more low frequency pattern control in the vertical plane. We have an array to adjust last row offset up or down to either put more sound in the back of the room or keep it off the glass concave wall behind the listeners. And we can also restrict the number of elements within a system for whichever reason you may have for that. And then we have our subwoofer options. And importantly, we have the calculate array button at the bottom, which is what really makes things happen. So we'll get into these a little bit more in the live demonstration. Once we click on the calculate the array after we dial in the parameters that we need to satisfy the spec. A suggested array is shown in the array tab, next one over from the start tab. And at this point, we need to transfer the array over to the EaseFocus 3 calculation engine so that we get a green array synced as opposed to array not synced. EaseFocus is still the acoustical calculation and reporting engine for VenuePolar, but you have to remember to send the information from the API over to it. I kind of covered this already. In the array tab, we can re-optimize filters if we choose to, using the button EF3 to VP button, and we'll take a look at that shortly. If you do re-optimize your filters, or if you choose to manually adjust the contouring filters or the attenuation filters, don't forget to transfer those changes back over to the calculation engine using the VenuePolar to EF3 button. Our loads tab, we've seen this a little bit already in our rigging safety check module. And put your desired safety factor in the screen and make sure that you're meeting the mechanical needs of the array or the mechanical engineer's desires. So examples. First things first. We have to accurately model the space that we are concerned with. Getting those seating sizes, elevation, scale correct, incredibly important. We insert our IV6 array. You can ignore the fact that it brings in a dozen cabinets to begin with. That's just the default. But we have to get our XYZ position of the array correct and our horizontal aiming angle, ensuring we intersect the audience areas of interest. Have to do all of this before calculating the VenuePolar. If any of that needs to change during the process, the height or otherwise, you will need to recalculate your array. We choose our target audience areas. We select our array characteristics, hit calculate array, and then transfer from VenuePolar to EaseFocus 3. So in this example, we have some slope seating planes with up to about a 65-foot projection distance. We have a 38-foot high array height. The top row of the seating is 36 feet, so pretty healthy rate to the seating. We calculate the array and transfer it from VenuePolar to EF3. For the parameters that I dialed in, which is I think 103 dB, it's told me that a 7-element array would be optimal, and this happens to be all 15-degree vertical elements. You see the attenuation profiles in there. You see your frame angle on the top of the screen, and we get pretty darn even coverage. This is looking at A-weighted mapping. And VenuePolar's answer gave us about a plus or minus 2 dB deviation over the listening area, which is generally very good for just about any application. But we certainly had height on our side here for this particular system. Let's take a look at a flat floor system, and we're going to go live here and go through a couple of these step by step. It's an 80-foot or about a 25-meter throw from where the speaker is located, a 27-foot, 8-meter high array height for this space. So hopefully Focus 3 shows up here as we expect it to. Again, flat floor space, and I've already drawn it out, obviously, just to save time. And we will choose our IV6 array 3.2, and I will select that. And just to start off, I'm going to place it in the center of the space. I'm going to turn off mapping for now because we haven't calculated anything. Again, it brings in a dozen elements to begin with because that's the calculation limit of the VenuePolar API, but we can ignore that for now. What we can't ignore is ensuring that our aiming line intersects the audience areas of interest we want to calculate for. And let's get our elevation correct. I'm going to say we've got a 27-foot elevation to the top of the box. You know, that 27 feet's not to the rigging point, not to the hoist ring, it's the top box height. So make sure you account for that when you're considering your rigging. Now I'm going to go over here to VenuePolar, and at first, first thing I need to do, which audience areas do I want VenuePolar to consider? Well, I'm intersecting the main area, and we've got the sound booth back here, but we'll concentrate on the main area for now. I could enhance the front row coverage if I choose to, which often adds an element to the cabinet, but I don't think for this, for this venue, it'll be necessary. I'm going to say I want a 97 dB system. I'm going to leave the default optimized to 800 Hertz. My last row offset, that's how much am I over aiming the last, over aiming on the last row. I'm not worried about restricting elements here, and no subwoofers at this time. And I'm just going to simply click on Calculate Array. So VenuePolar calculated my array. It says it's not synced because I have not sent it over to the calculation engine yet, but it's given, it's suggesting 6 elements will achieve, the SPL level and the coverage. So let's transfer that. You see over here on the left-hand side, our array is here with our 4 or 5 degree elements and our 15 degree elements. And our box and HF attenuation has also been transferred over. And let's take a look. I like to start in the voice band, so I'm going to use a 2K center and going to map based on A weighting. I'm going to click Show Mapping, and here's our mapping of the space. Looking at our array here, looks like our front row is covered fairly well, and our levels line going from front to the back of the room is tailing off about as I would expect. And it shows that, over at least in this frequency band, over about 61% of the space, I'm achieving 102 dB. I can look at this in relative mode, and I can see, for plus or minus, my plus or minus 3, achieving that over a very large percentage of the space. I could probably even look at plus or minus 2, and okay, a little closer to plus or minus 3 in most of the areas. But you can see, through using the contouring controls, how it has formed the vertical beam of our array to put less energy in the nearer seats and leaving the elements louder in the back, and also using the narrower 5 degree elements to project deeper into the space. A little bit easier to see if we go up on the higher frequency band. If we look at this broadband, again, I'm plus or minus 3 direct SPL over the space. almost plus or minus 2 through most of the space based on VenuePolar's prediction. Display plates have been selected. I can look at my rigging here, and it turns out that everything's been tight packed together. For this example, I did use the GlidePoint array frame, so I do have the ability to hang further back and combat the center of gravity of the system. So that's one way to do it. Let's take a quick look at what happens if we go to just using the light array frame pullback bar. So go over here to VenuePolar. I'll bring the array over, and here's what I say. I'm just changing rigging bars, which shouldn't affect my my filter. So I could choose to optimize filters or not. And looking at my rigging here, red dot being my center of gravity, I see that's actually behind the last point on my light array frame bar. You may choose to use the light array frame as a cost savings or for other reasons, but I'm now flagged in the status in the lower left-hand corner of the ease focus screen that a pullback bar is required. So I'm going to go in and change my box count to 7, and I'm going to make the bottom element my pullback bar. And now my flag has been cleared. I can see the pullback bar has shown up in my rigging. If I look at my loads tab, I can see that I'm at pinpoint 15, and my pullback bar for this particular configuration, which by the way looks like it still works well. I can see my pullback bar is taking about 112 pounds of weight. The goal is here to keep that top frame angle, maintain that minus 10 degree down point. So our pullback bar, the amount of weight on that bar is based on how much do we have to lift up the bottom of this array to maintain that 10 degrees down angle and put sound on ears. So pretty good outcome, there. I'm going to keep this particular array configuration, and we generally like stereo systems in this world. So while I've just done this as a mono center hang at this point, I could take my array over and snap it over here to the side, which is where people really want probably want it left and right. And I could just place another array in this corner and calculate it, but be aware if your position and orientation isn't exactly the same, you could certainly get a different answer with your attenuators. So I tend to just copy the array, but since we are projecting a further distance now, maybe we should recalculate the array and see if we get a different answer with our position being changed. And in fact, I did get a slightly different answer because the audience here that it's seeing is different. The distance that we're projecting, where we're intersecting, is different. So I'm going to transfer this over. I've kept the same numbers, 97 dB for the array. And now I've calculated my array, and assuming I place a second array in essentially the same spot, I'm just going to snap it here, and I'm going to just do a general aiming to line things up. But I could get very precise with my horizontal aiming here. We'll say this one's minus 17, and this one's 17 degrees. And if I calculate at this point, looking pretty good from that perspective. Let's look at our broadband coverage plus or minus 3, both arrays operating, generally plus or minus 3 dB SPL through the whole space. The sound guy's not hearing too much back here. Sound person, as it may be. We did not include that in the calculation originally. And it's grayed out up here in the box because the selected array doesn't actually intersect that point, so it can't consider it. So if I intersect this just a little bit with the array, and also bring the array I'm working on over, I'm going to choose not to optimize. I can recalculate the array, but now I can include the sound booths since I intersect that point. So I can calculate that array. Now the sound booth's in there, and you see it added another element because I'm projecting quite a bit further to get the sound booth in there. I'll transfer that to Ease Focus 3, and I'm going to do the same thing with this array, but I didn't intersect the listening plane of the sound booth. So let's try that again. And okay, array calculated, VenuePolar EF3. It's changed my attenuation, it's changed my cabinet quantity, but now the sound booth is in the plus or minus 3 range also. And you can see down here in the side view that we're projecting energy on them too. Now I might have been able to cheat a little bit and just tilt the array, last row offset up a couple of degrees to include the sound booth, but that's what we came up with. Oh look, we've got a flag back here. We recalculated the array, and again, VenuePolar won't add a pullback bar for you. So technically, I need to go in here and add a pullback bar on this array. And I need to add a pullback bar on this array also. Bring the array over, East focused, VenuePolar. I don't need to recalculate, but to get accurate loads and loading information, now that I have a pullback bar, I do need to transfer each array back over. And now my loads, my loads and showing how much weight my pullback bars will take is available in that tab. And my mapping is still, essentially the same, looking at broadband here. Okay, so that's one example. Perhaps I wanted, if I wanted subwoofers within the system, whether they're ground-based or flown behind the array. If I wanted subwoofers, behind the array, I could certainly go based on the predictions, or I could have VenuePolar figure out or give a suggestion. Oh, lost that. I could tell it I want subwoofers behind the array, and sorry, getting tripped up here. Calculate behind the array. And I'm making a mistake here. Okay, so it's you could place subwoofers behind the array. It suggests three subwoofers. I can synchronize this, change these to subwoofers behind the array manually. I could also decide to just place the subwoofers on the floor as a ground stack once I calculate it and select my audience area, and it'll make a recommendation for how many subwoofers that I want. Again, we get deep into that, but we can do a ground stack, and again the subwoofers will show up in the report. And before I forget, I'm going to create a report of this system just to show you all the information that is contained in that report. So my last selected array, it will provide the mappings for us. Since I didn't have a mapping on the screen, nothing's shown at the moment, but just to show you the detail it goes into, shows from my XYZ position, you know, of the last array that I worked with. It shows our rigging angles, our aiming angles, you know, between each element. Shows us that our you know 10-to-1 safety factor was met. Here's our contouring settings. Shows us our attenuation settings on a per box basis to be applied to the elements from top to bottom. Shows that on loads, single hang point, pinpoint number 14, plus the pullback bar, which is also listed. It shows how much weight that pullback bar is taking. And the current array, that is the one that I had selected, highlighted in red, is shown here for a bill of materials. For the single array, I can scroll down further into the report because we did have 2 arrays in the system, and this shows 4 light array frames because I was using one on the top of each array and a pullback bar, how many of each element type, and how many of each splay bracket type for the arrays that were shown. All right, moving rather quickly here, but hopefully it gives you a good idea and a good starting point for where to start in the VenuePolar tab. Again, aim lines must intersect audience areas. Make sure you transfer your VenuePolar calculated array back over to the calculation engine each time. Check your loads, make sure you've met your safety factors, make sure you have no red flags in your status down to the left or down in the right hand corner here to ensure that you've got a mechanically stable array and you're not doing anything that's not allowed. All right, so that was kind of the quickest demo I can do. In the report, as I just showed, we have all these attenuator settings, which for each of our full range elements will give you a position like, C0, for the box, or, C0 being no attenuation, for the top box, or if we look at one that's got attenuators like box 7 in this example, it was -3, so you would go to, section B and then 1, and then the high frequency attenuation would be 1.5 for that particular one. Bill of materials is included, as we saw. Question that we get often, how many watts do I need? Well, in general, 4 1122 boxes is a 4 ohm load when unattenuated. We suggest an ALC 1604D bridged, 2 channels bridged to achieve maximum SPL output. When you get to 5 or 6 elements, our ALC 3202D may be applicable. When you get into those, 3, below 3 ohm load needs. I've got 7+ boxes in array. We typically find that you need multiple 1604D or 3202D channels to drive the array to max SPL. Single 118 subwoofer, whether it's in the array, on the ground, behind it, a bridge 1604D will bring it to full output, or a bridge 3202D if you're running dual 18s in some configuration. We have a downloadable array impedance calculator for more complex arrangements, or just to check what your nominal and minimum impedance is to help you match up amplification appropriately. We've given you a pretty good start already. You can find this a cross-reference for all of our speaker lines the Biamp, community branded speakers online. I think this is in Cornerstone and can be searched out a number of ways, but you'll see the initial suggestion is for the bridged ALC 1604D for an array, and also for a single 18 subwoofer system. When we're calculating the impedance of our loads, for an amplifier, we're only considering the full box attenuation within the system. So if we look at our report at our passive filter settings, it doesn't really matter what order you enter them in, but we're only looking at the box attenuation since the minimum impedance happens down around 250 hertz or so. That's the one we're concerned with. And we dial in using the drop downs in the simple Excel sheet to dial in, what our attenuation settings are. And then we get an answer down here, what our total nominal impedance is and what the system minimum impedance is to aid you in amp selection, and also to, consider what size wire gauge do we need to maintain minimal loss. And for subwoofers, obviously, we'll always want to use as much copper as we can to maintain our damping factor. But this calculator is only calculating for the full range arrays. If you're using a very long array, again, you might choose to distribute it across a couple amp channels. You get into 7 and 8 boxes, and you can assign different amplifier channels over here on the right-hand side, and get your answers for each of those so you know what sort of impedance you're working with. If you choose to adjust your passive filter settings, you can do that in the Array tab in the VenuePolar API. If you just want to, crank it down to, looking at, relative of, -2 or -1 and start, chasing dB.5 increments, you can do that. But you see the answers that I got in the examples were pretty good out of the gate, but you have the ability to adjust these on your own. Just don't forget to hit the VP to EF3 button to apply the changes in the calculation engine and then recalculate. Again, you can, we can design our own mechanical array depending on the needs of the space. In VenuePolar, you click the East Focus 3 to VP to bring it over to the calculation engine, and then it will ask you if you want VenuePolar to optimize the filters, or you can do it manually if you choose, and then send the information back over to the calculation engine. Allow VenuePolar to calculate display, not Focus 3. Let VenuePolar do what it's really good at. And also, let's remember to keep our gains on the East Focus 3 side at 0, because they are additive to any sort of attenuation that you may add in the VenuePolar plugin. Audience areas must be fully intersected by the 1122 speakers to be considered in the calculation. The front of the aiming line and the aiming line must intersect the front and the back. If you have an array over a seating section, VenuePolar cannot calculate and optimize for that seating section. So either cheat for a moment and slide your section back if it truly is going over it, or consider if you're going to need some front fills or something of that sort added to the system depending on the array location. But point is, when you're selecting what to calculate for, we have to intersect all audience areas we want to consider fully. So wrap up, VenuePolar is an extremely powerful tool which will save you time by shortening the design process. It'll suggest appropriate configurations based on your input. There's no magic here. Well, it is a little bit of magic in there, but it's bound in good old-fashioned physics and acoustics. But you have to, you've got to get the model right, and it'll give you a complete speaker and rigging BOM at the end of the report. input data must be good to produce, good results. That includes, room dimensions. You got to make sure your scaling is correct and your elevations are correct, both for the array and any changes in elevation to your seating. And during your site survey, you've really got to qualify the room, acoustically. Is it appropriate for, say, a left-right system, of a stage? Or does it need deeper investigation for the acoustics, perhaps in EASE-4 to qualify it and make sure that we can get appropriate intelligibility? Because again, VenuePolar, EaseFocus, they do not consider room acoustics. Every room is perfect to them and has a reverb time of 0. So got to get it right. A lot of information in a very short time there. I thank you for taking the time to review VenuePolar GLL 3.2 release with me today, and have yourself a fantastic day or evening.